Hello, sixth grade students. Mr. Flick here, and I'm going to help you guys out with a little assignment that I'm posting here. I know it's very difficult to um, know how to do these things when you don't really get to hear our conversations in class. So I'm going to go ahead and go through our next assignment with you because we did all of this pretty much together as a class, except for I'm going to let you do some of these down here on your own at the end where it says you try. Okay, but this stuff, all of this stuff up here, I'm going to go through it with you and tell you how to do this. Okay, so this little assignment is it's kind of just like a lesson over speed and velocity. So we've talked a lot about reference points and distance and displacement and position and things like that. So hopefully you're feeling pretty good about that by now. um, if not, just make sure you send me emails with questions, and I will be happy to create more videos like this if you need it. But let's first off look at this sheet here. So we're just kind of doing some notes, and we're learning some new terms today here. Okay, so we're going to talk about speed first. So we're going to start on this first page, speed, and you will probably have to. I'm using Adobe to edit this, but you guys will need to use Cami. So it seems like you all know pretty well what you're doing with using Cami. So we'll start here at this little cloud. So we're talking about speed. And speed is it's a measure of how fast something is going. I'm sure you've all heard that word before. So, but speed specifically is something that we call a scalar quantity, and that is spelled like this: SCALAR, scalar. And what a scalar is it's a quantity is just basically like how much of something, or it's a number. So a scalar quantity is fully described by one numerical value. So when we say something like 60 miles per hour, we're just talking about one numerical value. So it's just talking about speed only. So is a scalar quantity is fully described by one numerical value. And that's what speed is. We call speed a scalar quantity. I don't get too hung up on that term scalar. I just want you to know what that means, okay? So again, we're gonna bump over to this box now, okay? So if you have to pause every once in a while watching this video to get these notes in, you should do that. Okay? I'm gonna start actually highlighting these first in the notes. So speed, again, we're gonna use the same term here. I'm gonna change my text color to red. That way it's a little easier to tell it apart from everything else. So a scalar quantity, speed is a scalar quantity that describes only, now here's a new word for you, only the magnitude. Magnitude. And magnitude is just how much of something there is. That's what magnitude means. So that describes only the magnitude of the rate of change in an object's motion. Because really that's what we're doing with speed is we're determining an object's motion, how fast it's moving. And determining an object's speed requires a unit of distance, okay? Distance per unit of time. And what that means, well, it means it's a division problem. Anytime you see per something of, that means it's division. So distance divided by time is how we get speed. So determining an object's speed requires a unit of distance per unit of time. Distance divided by time. I don't know where all my, oh, they're still there. Okay. So again, if you need to pause, do that so you can get your terms filled out there, the ones that I'm putting in red. These are the ones that we want to type out ourselves, okay? Because these are kind of like notes that you can study. And you can make those red yourself if you want to kind of help you see which words you want to learn. And it doesn't have to be red. You can make them bold, whatever you want to do, okay? So we have a little problem over here. It says Mr. Fast is speeding down the highway and travels 2,560 meters in 60 seconds. What is his average speed? Well, again, it says right here, determining an object's speed requires a unit of distance per a unit of time. So that means distance divided by time. So we would need to take a distance, and in this case, it's 2,560 meters divided by a time. And what we have in our time here is 60 seconds. So let me get you guys can, in science class, you can always use a calculator. You don't have to do these things by hand. So we're going to go 2,560 divided by 60. That's going to give us a decimal here. So 42.6, a bunch of sixes and a 7. So we're going to round. So just to keep it real simple, let's just change it. Since this number is over 5 right here, we're going to change this number to a 3. So we're going to round up from 42.6, repeating to 43. So the answer that you would want to put, so I have to add a text box right here. So our distance is 2,560 meters divided by 60 seconds. And our answer was 43. But we have to write a unit. And a unit is something like miles per hour or kilometers per hour. But in this situation, we have meters and seconds. So we're going to say 43 meters per second. And the way you write meters per second is an M, a forward slash, and S. So our answers there are 2,560 meters per second. Or sorry, 43 meters per second. He'd be going real fast. He was going 2,560 meters per second. Okay, so there's speed for you. Again, go ahead and pause if you need to catch yourself up on this stuff right here and all of these terms. Okay, so I'm going to go ahead and move on to velocity. Now, velocity is a little bit different. We're going to start again in the cloud here. Velocity is what we call, it's a different kind of, the other one was called a scalar quantity, and it only measures one thing. But velocity measures two things, so we call that a vector quantity. Let me get this. I don't think I'm editing anymore. Okay, there we go. We call it a vector quantity, and that's spelled V-E-C-T-O-R. So a vector quantity is described by, hang on just a second here. I'm going to make this look a little neater. Okay. Now, vector quantity is described by the word you'll put here is both a numerical value, because remember the scalar quantity was only a numerical value. The vector quantity is both a numerical value and the word is direction. Okay? So velocity measures both a numerical value and direction. The numerical value would be the speed. But then we would also have to talk about what direction we are going to make it a velocity. So again, we're going to write over here too. Remember, feel free to pause if you need to catch up. Velocity is a vector Whoa, I spelled that weird. Vector quantity that describes both the magnitude. We're going to use that word again. And again, magnitude means how much of something. That's not how you spell magnitude. Magnitude. Lots of typos here. Sorry about that. So a vector measures two things. It's going to measure the magnitude of the rate of change in an object's motion. Okay? Rate of change in an object's motion is its speed, plus it describes its direction. What direction it's going. Okay? An object's overall change in position is known as its, and this is a word from our first couple of lessons, the difference between the first and final position of an object, and that word is displacement. Okay? So velocity is a vector quantity that measures two things, not just one. It measures a numerical value, the speed, and a direction. Okay? So in an object's overall change in position, we call that displacement. And we've talked about displacement, but we really need to know what displacement is for this part because that's how we measure velocity. So if you look back up at speed, we had distance divided by time, d divided by t. Well, for some reason, displacement is actually it's abbreviated with an s, which is kind of weird. You would think it meant speed, but it doesn't. It means displacement. So for velocity, we're going to go displacement divided by time. And here, Mrs. Swift travels north for 75 kilometers for 1.5 hours. What is her average velocity? Okay, so we got 75 kilometers for her displacement. Put that right there. And we've got 1.5 hours for her time. So velocity equals displacement divided by time. Let's get our calculator out again. We had what? 75 divided by 1.5. 75 divided by 1.5. Our answer here is going to be 50. 50. So her velocity is 50 kilometers per hour. So we go km/h /h. That's how you would write 50 kilometers per hour. Or some people just leave that / out altogether and just do kmh. But I prefer personally this way. So that's velocity. So velocity is when you have been given a speed and a direction. So if I said, here's a velocity kind of right here. She traveled north for 50 kilometers per hour north. And honestly, I'm sorry, I should have put that right here too. You need to also add north. 60 kilometers per hour north. That's very important. When you're writing out a velocity, you have to have a direction included. Because if you don't include a direction, it's just a speed. So 50 kilometers per hour north, that is our answer for velocity. Speed and direction. Okay, that's two values. That's a vector. One value is a scalar. One value, numerical and that's it. Vector is numerical and direction. So I'll show you what to do. I'll do two of these with you, and then all you guys have to do by yourself is the rest of these here, 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 and here. And then remember our formulas from up here. You can look right back at them. To get speed, it's distance divided by time. And you just give me the unit of something per something. Could be miles per hour. It'll end up being kilometers per hour right here. This is velocity, though. And so you'll have to, whatever your answer is, your unit will be kilometers per hour west because it's a velocity. Over here, though, it's just asking for a speed. So you'd take you'd go distance divided by time, and you would just say we have miles and hours. So this one would be miles per hour, and miles per hour is written mph. Okay, so let's look at this one. This says 5.5 kilometers per hour. So remember that speed is a scalar, so it only gives us one numerical value. Velocity is a vector. It gives us a numerical value and a direction. So it's two things. I only see one thing here. I just see 5.5 kilometers per hour. So that tells me that we have a scalar thing. We just have a number. We don't have a direction in here. So we're going to make this one the letter S for speed. This one says 65 meters per second north, in for north. That sounds like a vector to me because not only does it have a numerical value for speed, but it also has a direction. So on that one, we know that we've got ourselves velocity. Okay? So that's all you're doing in these blanks is you put an S or a V. If you think it's speed, you put an S. If you think it's velocity, you put a V. And then over here, you get your calculator out and you take displacement divided by time for velocity, and distance divided by time for speed. Okay? I hope that you guys have been helped by my video here. And if you have any further questions, please do not hesitate to send me an email to ask me, okay? And I hopefully we can all get you back to school here pretty soon. Definitely miss you guys. So we will see you around. Have a great day.